Hey guys, welcome back to my YouTube channel, and in this video we are going to discuss one more problem on backtracking, right? And this problem is related to trees, correct? So what we'll do, we'll first understand what exactly is the problem statement. After that we'll try to solve using backtracking. So the problem is you'll be given a tree like this, and along with this tree one more thing will also be given, that is target sum, correct? Target sum. And what you need to do is you need to find out all the path that is from root node to leaf nodes. These four nodes are leaf nodes. So from root to leaf whose sum is equal to target sum, correct? Let's assume that the target sum is equal to 17. Now let's traverse this tree. So take this path, 2 plus 7 plus 6, which is 7 plus 6 is 13, 13 plus 2 is 15. This is not equal to target sum. We'll ignore this path. Again 2, 7 and 8. This is the second path from root to leaf. 2 plus 7 is 9, 9 plus 8 is 17. And this value is equal to this one, that is target sum. So what we need to do, we need to print this path, 2, 7 and 8. This is the path. Let's test another path. 2 plus 4 is 6. 6 plus 9 is 15. This is 15, and which is not equal to target sum. So we'll ignore this path as well. The next one is 2 plus 4 plus 1, which is 7. And this is again not equal to 17, correct? So the answer is this 2, 7 and 8. And we need to print this as an output. This is the problem statement, right? Now let's try to understand how we can solve this problem using backtracking. Alright, so this is the code for it, and here I've created this function which is getPaths, and these are the four parameters 1, 2, 3 and 4, correct? This is the root node, right? Here I've created one vector for storing all these elements. This is the target sum, and this is the sum variable whose initial value is 0. Okay, now the first condition is if root is equal to null, then we just need to return to the main function. Let's say if we don't pass any node to the function, then we just need to return to the main function, correct? This is the base condition. After that we are just pushing the element into this vector, so this is the vector for that. Again, after doing that, we are just adding the element into some variable, correct? Now let's traverse this on this tree. So the first one is if root is equal to null, which is false. Line number 33, we just need to push that element to the vector. Let's say this is a vector, okay? So we dot push back root of data, so root value is 2, so we'll just push 2 here. Again, sum plus is equal to root of data. Initially sum is 0, so now sum becomes 2, correct? And here we are just checking whether the node is leaf node or not. Okay, so here there are two conditions. The first one is the condition for leaf node, which is this, and the condition for whether the element is equal to target sum or not. Means we are just checking whether some value is equal to target sum or not. And if these two conditions are satisfied, then we just need to print that path. Make sense? So this is the condition for that. See, here the sum is 2 and the target sum is, let's say it is 17, right? So here this condition is not satisfied, and at line number 40 and 41 we are just passing left and right child, means these two cases are recursive case. Okay, so first we need to check at the left node and then at the right node. Okay, so here it is left, then we'll go to 7. Again we just need to push into this vector, so 7 is pushed into this vector. Then at line number 35 we just need to add in the sum variable, that is sum will become 2 plus 7 is 9. Okay, it is 9. And again this condition is not true because sum is not equal to 17, correct? And at line number 40 we just need to traverse its left child, so now the root node is 6, correct? Again we are back to this step, so node is not equal to null. We dot push back root of data, so we'll push 6 here, and we just need to add this into some variable. Now sum becomes 9 plus 6 15. Okay, Again, at line number 37, we just need to check this condition, which is false because target sum is 17 and the value of sum is 15. Okay, so this condition is false. Now, line number 40, we need to traverse its left child. Now, left child is null, so this condition is satisfied. We'll return back to the same function. Now, we need to traverse its right child. Okay, so right child is also null, so we'll return back to this. Okay, and everything is completed for this node, so we'll jump onto its parent node. Correct. Now for parent node, its right child is pending, right? And before that, we just need to pop out the element which we have pushed, that is last element. So we'll remove 6 from this vector. Okay, this is called backtracking. This step is called backtracking, right? Now again we are back to this condition, root is not equal to null. Now we dot push back root of data, so we'll push 8 in this vector, and now the value of sum becomes, see, sum is also got changed because we are back to previous call stack. Correct. So sum value will be 9, and we just need to add 9 plus 8, which is 17. So now the sum value is 17, which is equal to target sum. This condition is satisfied, and this condition is also satisfied because root of left is null and root of right is also null for node number 8. Correct. So we'll print this path, and yeah, that's it. So this is how we can traverse this tree and find out whether any path is existed in this tree whose sum is equal to target sum, right? And this is the code for it. Let me show you the original code. This is the code, and here I've created this print paths function for printing all the path, and we just need to call this function in main. This is the function name. Correct. Now let's run this. See here, this is answer 278, 2, 7 and 8 whose sum is 17. Okay, so this is how you can find out whether there is any path from root to leaf whose sum is equal to target sum or not, and this is the code for it.